I'm Professor Zhang from UCSD. I'm an assistant professor there working with data center systems. So we see a lot of students are interested in knowing more about tech startups, and both from the successful business side and also from technical side. That's the main reason why we are conducting this type of interviews. And thank you for doing the first one.
No, thank you so much for coming all the way and talking to us.
So maybe we can start from you introduce yourself a little bit.
Yeah. So my name is Amit Prakash. I am one of the co-founders and CTO of ThoughtSpot. So ThoughtSpot is about 7.5-year-old company. We are in the analytics space. And what we have done is basically build a new kind of architecture that allows several billion rows of data, several terabytes of data to stay in memory. And then we have built a question answering interface on top of that so that any business user can ask questions off their data and get back responses as if you're getting it back from Google, kind of similar response time. And then we've built a machine learning layer on top of that that's constantly learning from the users about the context of the data, so that when you trigger our another product, which is called Spot IQ, it essentially asks questions on your behalf based on what it knows about the data. So it might ask questions that you may not even thought of, and it can run through thousands of questions and find interesting nuggets of information in data and bring back to you. So essentially, what we're trying to do is build sort of the next generation analytics product where the users have to put as little effort as possible and get as much value from their data as possible.
That's very interesting and impressive. So I do have a lot more like technical side of questions, but maybe I'll start first from your how the ThoughtSpot actually started, what you are experiencing that. Like initially, how did the founding team actually found a good problem to start to work on, and how do you find a business model on top of that?
Yeah, so before starting ThoughtSpot, I had spent about 5 years at Google, and my team was responsible for the machine learning infrastructure and building machine learning models that would predict when somebody is going to click on an ad, right? And if you know Google's revenue model, most of Google's revenue comes through ads. And so my sort of extended team was responsible for that revenue. In terms of every quarter, we're supposed to increase that revenue by a couple of % with algorithmic improvements. And in those days, AdSense used to get about 30 billion ad impressions a day. So you can imagine the amount of training data you would have if you go back 2 years or so. So we were training machine learning models that were maybe 2 orders of magnitude larger in training volume and feature size than anything else that I have seen published. And so we were in the business of building really high performance distributed systems that could chuck through a lot of data. And at the same time, in ad business, being able to update your model really, really quick based on what's happening when new advertisers are coming into system and maybe exploiting something, or new ads are coming into system, or new publishers are coming into system, you have to quickly converge to the right value for them. Otherwise, you're essentially losing a lot of value in the network. So we were building models that could kind of consume large volumes of data and quickly update it. And so I'd done that for about 5 years, and I wanted to figure out what I wanted to do in my career next. And entrepreneurship kind of came naturally. It's like being in the valley and not getting inspired by what's happening here is very, very hard. And at the same time, my co-founder, Ajit, was one of the co-founders and chief product officer at Nutanix. And at some point, he decided that he was going to step out of Nutanix and start something else. So we just happened to meet each other through a common friend. And we started brainstorming what kind of problems we wanted to work on and what did we want to bring to market. And Ajit has a very interesting way of looking at things. So his hypothesis is that, like, whenever you're starting a company, the most important thing to get right is the market. And when you're starting a company, you have to take some sort of a risk. Otherwise, what's the point of starting a company, right? But you can bucket that risk into two different categories. So one is execution risk, and the other one is the market risk, right? So if you're trying to build, next Facebook or next TikTok, the technology to build it for at least for a few thousand users is actually very easy. Almost anybody can build it. So there's very little risk in terms of you being able to execute to that vision. But there's a huge market risk because you don't know your new form of interacting with the social network may or may not fly. Why would people leave the current networks with lots of user base and come in? On the other hand, if you're, let's say, trying to build a SpaceX or self-driving cars, it's something, not so much about SpaceX, but for self-driving cars, there's going to be a huge market out there. And it's almost a given that everybody would want to use those things when they are there in the market. But it's an extremely hard problem to get it right. And so all the risk lies on the execution side. And so we deliberately wanted to pick a problem where most of the risk is on the execution side and less on the market side, so that if we have the confidence that we can solve the hard problems related to that and go to market, there's already a fairly big market existing for it. And then we don't have to create a market for it. And in that sense, we are kind of in control of our own destiny, as long as we had the confidence that we could solve some hard problems related to a market that's already existing and people are spending a lot of money. So with that lens, we started looking at problems. And the other thing was we wanted to work on something that we bring our strengths to, so that we know that we can solve those related hard problems. So I was doing a lot of ML at large scale at Google. And the flip side of machine learning, when you are in this phase of constantly refining your models, is really analytics, right? So what is the next feature that is going to give you the benefit? The way you look at it is basically you look at the residue, right? What are you predicting and what is the reality? And along which axes you're seeing a lot of concentration of residues, right? If it is evenly spread, then that feature doesn't have a lot of predictive value. So you're constantly trying to analyze over trillions of rows of data, which feature is going to be interesting. Maybe if the user has seen the ad 10 times, the chances are next time they're not going to click on that ad, right? So now you've got a feature that how many times the user has clicked on it. Do you have additional residual sort of variance that correlates with it? And so we were doing a lot of analytics over there. So I was kind of familiar with that space. And Ajit had spent significant amount of time before Nutanix at Aster, where he had worked in this industry a lot. So we were familiar with the space, and we knew that most of the technology in this space was about 20, 25 years old. And the most recent innovation in the space had basically come from Tableau, where what they had done was they said, like, if you have small amount of data, something that will fit in the memory of a single server, then we can kind of load it in memory and give you easy way to interact with it. Of course, the main innovation they had was beautiful visualizations came out with very little effort. But what we saw there was that the market was very happy. So a lot of people were very happy with those products because they could just swipe their credit card, get a Tableau license, and start doing their own analytics, as opposed to waiting on sort of the traditional previous generation analytics, which was Oracle BI and Cognos and Business Objects, which was messy and took long and needed someone from IT side to build these things, and in many cases it took several days for them to get an answer, right? But the limitation with that market was that, the limitation with Tableau and to some extent Qlik was that they were designed to be single node solutions. They kind of grew out of being a desktop tool to being a server tool, but they were never designed as a distributed system. So they saturated at, like, from various accounts, 10 million to 100 million rows. And after that, things kind of either didn't work or became very, very slow. And in modern enterprises, the amount of data has been growing quite a bit. And that's been kind of always the challenge with the analytics industry, is that the amount of data you have to what you can really interact with, there's a big gap. So what people have been doing is guessing the questions ahead of the time, which is where the requirements for report building comes in, and then pre-aggregating so that you kind of have those answers mostly cooked already, and then you can do a few variations there, which works great till you come up with a new question, right? So that's what's happening in industry, or has been happening in industry in past, is you kind of go through these 3-month, 6-month cycles of gathering requirements for a dashboard. You build a dashboard, and then the first time someone has a question, it's not answered by it. Now you're looking at a week, maybe a month long wait. And so we thought that if we could solve that problem well, then we would have a winner in our hands. And so that was kind of the origin.
Thank you very much for the very detailed answer. So one thing you mentioned early in the answer is like this very interesting perspective of like technical challenges versus market challenges and risks. And you choose to find something that will definitely have like a good market first, and then something that you think you have like a advantage of solving on the technical side. So for this type of market, if it's already mature enough, like how much do you worry about if other people have already have certain solutions like Tableau, or maybe newcomers, they also have come up with solutions?
So I think there are a couple of things there. So one, obviously, you cannot win as a startup if you're not innovating fast. That's the only thing that's going for you, is that you can focus on a particular problem, not worry about anything else, and innovate like hell. So as a startup, if you're worried about somebody else doing the same thing, that's never going to work. Because somebody else is looking at the same market, same circumstances. And if you can't innovate faster than them, then you essentially don't deserve to win as a startup, right? As far as established companies are concerned, I think what happens with established companies is that they have status quo to defend, and that means old ways of doing things. And so everything becomes sort of looking at it from that lens. And when people think about sort of what should be the next generation, it's usually very, very incremental. And you can see this across the industry. It's that when people who are very few companies, large companies, are good at disrupting themselves and their own products. They would kind of take something that's really good, that's working for them, and incrementally do something. And the third thing is timing, right? So when we decided that we are going to build a distributed in-memory database that's going to hold all the data in memory, it was the right time for it because DRAM prices were going down and gone down significantly in the last few years. So we could make this reasonable calculation that the cost of hardware to hold this data in RAM is going to be okay. Whereas when Tableau was being designed, when Oracle BI was being designed, or business objects were being designed, that wouldn't have been the right design point. And because they're working with a fairly successful legacy system, it's very hard for them to kind of turn around and all of a sudden design something else that's a completely different design point.
Okay, interesting. I have more questions on the memory side, but before that, let me still focus on one more high-level question. So, since you focused on the mature market, how much growth value do you think that market has? Especially because like you are focusing on relational database. What about all the other data storage, like NoSQL and other type of data analytics?
So this answer may be a little bit controversial for a lot of people, but time and again, I'm seeing that markets kind of deviate from SQL and then come back to SQL. and the reason for that is basically a lot of applications are written with the SQL interface, and it's a very, very sticky kind of interface where you see that's what happened with the whole Apache Hadoop ecosystem, right? People went and said, oh, SQL is old, we're going to do a lot of map reduces, and then they built Hive, and that was one of the Hive and sort of Impala, and that was one of the more successful things. On the Spark side of things, a lot of different things happened, but kind of Spark SQL seems to be picking up in the market, at least from my vantage point. Maybe that's not what you see. So I think the NoSQL databases have found their place in the market. But if you ask my prediction, and like I said, it's going to be a little bit controversial. I think SQL-based databases are going to continue to dominate, at least for some years, is kind of my thinking, maybe different than what you're thinking. And as far as market size, so we were forced to build a distributed in-memory database that works really, really fast. But that's not the business we are in. We are not selling an independent database in the market. We view ourselves as the last mile of analytics, right? So, and we will do whatever is needed to build sort of the best possible experience we can build for sort of an average end user, non-technical user, to be able to get the benefits of analytics from their data. And so if that at some point that required us to go build a really, really fast in-memory database, and we built it. But at some point we may go do something for NoSQL as well, or we may start sort of integrating with other NoSQL things. So we firmly believe that what we're selling is that user experience where any user can come in and ask questions or just specify what kind of insights would be valuable for them, and the system just gives them those insights with as little effort as possible. And the rest is kind of just the machinery to get there.
So you mentioned innovation and disruptive technology several times.
Yeah.
So do you think that is what is actually your main innovation or technical selling point?
Yeah. So it's if you survey the sort of technical product startups, particularly enterprise startups, to what most people build versus what ThoughtSpot has built, you'll find that we've been a little bit on the crazy side in terms of ambition. So we started with this vision that anybody should be able to ask questions almost like they do in Google or Amazon, and get back answers to analytical questions. And then we started working backwards from there to say what all needs to be built to create that experience, right? So the first thing was having the right interface. Actually, more conceptually, not in the sequence in which we built things, but conceptually, the first thing to get right is the user interface in which somebody could ask an analytical question and get back an answer and kind of do their job with it, right? And that in itself is a very interesting question because the world is very familiar with Google and Amazon and Kayak as sort of search model. But this is a little bit different. It's a little bit different because mostly when you talk about search, it's about finding information that already exists out there. When you go and ask Google to give you a poem about fall, it's not going to go and compose a poem. It's going to find somebody who's written a poem about fall and bring it to you, right? Whereas when somebody comes and asks me what's the most profitable product I have in Southeast Asia in last 3 weeks, that doesn't exist anywhere. All I know is all the individual transactions that have happened. And so I need to go and compute from there, right? So essentially, we are using a familiar search paradigm, but we are using it more like an IDE that a user is asking us to do a computation in a very simple terms, but it's essentially specifying a program, right? So that's one difference. The other difference is that a business user is not going to like it if we adopt a typical search methodology of they say, what's my most profitable product in the last 3 years? And we give them 10 answers and say, you go figure out which one it is, right? Like Google will give you 10 blue links and say, you go figure out which one it is. We think the first one might be the one you're looking for, but no guarantees, right? So if someone says how much revenue we had last year, it has to be one precise number. It can't be 10 numbers. And the user has to understand how we interpreted the question and what is the question for which they are getting the answer, right? So that interface itself took us a lot of iterations and just trial and error to get to a place where we could build an interface where most end users would be comfortable asking a question, getting an answer, and running with it and doing whatever they needed to do based on that answer, right? And so we are in a way a very serious systems company and machine learning company, but the product kind of stands on 3 legs, and all 3 legs are equally important.
Okay.
So there's distributed systems, there's machine learning, and there's user interface. And these 3 things are kind of critical to delivering the experience that we deliver, right? The second thing was obviously this search interface has to work. That means when someone asks a question, I should be able to interpret it, guide them towards the right questions, because a lot of times, just like when you go and Google and you might be searching for Arnold Schwarzenegger's latest movie, you may not know how to spell Schwarzenegger. Right? So auto-completion is kind of a critical part of this search as well. And then sort of parsing it, understanding it, adding enough details to the question that the user may not have added, right? So user might ask you for revenue for shoes. Now, is shoes a product? Is it a product category? Is it a product subcategory? Is revenue in the same table as a product subcategory? If not, how do you join it? All that information needs to be filled in. And so essentially, some part of the information that the user is asking is being provided at the query time, but some part of it is being provided at the modeling time, where somebody else has kind of created a schema, defined joins, and things like that, and sort of fusing all of that is kind of the second, our search engine technology. And if you think about it, it has, again, 3 pieces. One piece is pure indexing. So what we'll do is extract every string in your database, every entity, and put that in a very efficient indexing structure that's, again, like we came up with some of the algorithms for it and patented it. Didn't exist before. We might write a paper about it at some point, but we haven't gotten to it. And so we had to build basically a distributed indexing system that can potentially have 1 billion strings in there. And you can send a query that says the user has typed CALI, find me all the strings that may be a potential match for CALI that this user is allowed to see and make sense in the context of the question that the user is typing. So the user is typing revenue for CALI. So now it's obvious California, but like the context that revenue for means that it has to be some entity for which you can filter down revenue, and then it has to match something in your database. And it has to be able to do that under 5 to 10 milliseconds, because when someone asks a question, there are lots of hypotheses about maybe we segment it this way or this way or this way. And so all those hypotheses need to go to index and be tested and come back under 100 milliseconds. So that it still feels like Google-like, where you hit a keystroke and it comes back with a response. So there's that piece. Then there's a little bit of compiler-like technology for parsing what you're asking and interpreting, and then giving you auto-completion suggestions. And then there's the machine learning piece, which is constantly learning based on what you have done in past, that you often ask questions about revenue, whereas the other person asks questions about marketing campaigns, or this HR person always asks questions about attrition risk or something like that. And when they do ask for that metric, the next thing usually is for a particular person, for a particular region, for a particular marketing campaign. And so sort of ranking that so that we can give you sort of your next step right away, as opposed to you having to type the whole thing. So that's the search piece. But then the next thing was that you can't call it search if you ask a question and it comes back in 3 minutes or 5 minutes, right? Then it doesn't feel like Google, right? And we wanted to build a product where it's for the enterprise data. So, like, for example, one of our customers is putting 100 billion records in there. And so, and this is all unaggregated because we allow you to ask questions in any direction. So pre-aggregations don't work. So how do you scan and aggregate 100 billion rows of data and come back in a few seconds? That required us to build a distributed in-memory database. And we had started with that vision that we wanted to be able to aggregate across several billion rows of data and come back under a second. And we evaluated pretty much everything that existed out there to see if we could get that kind of performance without having to build it ourselves. And nothing came close to it, even by an order of magnitude. And so then the only thing that actually gave the performance that we wanted to get was if I hand wrote a C++ program that kind of ran over a for loop over a hash table and aggregated it and then gave me the answer. And even moving from C++ to Java dropped performance by 4x. So we ended up designing a system where, as the query comes in, we generate a C++ program that's as close as possible to what a developer will write to compute that answer, and then run that on data structures that's sitting in memory. And that's what gives us that tremendous speed. So, and then now what we're trying to do is sell our distributed systems to customers who have no experience running and managing distributed systems, many times on-prem, sometimes in cloud. So we had to build another sort of orchestration layer to sort of host all these services that takes care of what service is getting scheduled where, and when machines go down, processes go down, taking care of all that. So,
There are definitely many challenges in this whole space, and now I see why it's a real hard problem. So how much you mentioned? So one thing that interests me is you mentioned this like milliseconds or how many seconds? Like limits that you have to deliver to users search queries. So how much of that can be cached? How much caching would help?
So there are two kind of latency design points we have. And one is for how quickly the search system responds. And this is basically auto-completion and responding to query with sort of an understanding of the query, not so much running the query, right? And that, our design point was 100 milliseconds. Because every time you hit a keystroke, we want the search engine to come back with what it has understood and what possibilities exist there, right? And then when the question is complete and you're firing off a query to the database, we wanted to build a system that for the most part, responds under a few seconds. Now, obviously, with the data volume, concurrency, and query complexity, there's a wide range. But typically, that's what we shoot for most implementations, that most of the queries come back under a few seconds. And what we typically see is about 70–80% cache hits. So questions were answered earlier with the same underlying data, because data also keeps changing, so then caching doesn't work. So some customers update the data once a day, some customers update every hour, some customers update every few minutes. So even though the question may be the same, the answer has to change. But in most cases, we see about 70% or so cache hit rate for results. And then we see about 90% or so in most good systems cache hit rate just for code generation. So we don't have to go through compile step and planning and code generation. So caching definitely helps a lot. Without caching, we'd be in deep trouble. But there is still a substantial amount of things that fall through the caches, and you have to do it.
Yeah, and I guess you still have to go to the bottom of it to solve the rest, 20 to 30% of the workloads.
Yeah.
Okay, so let me move to more to some high-level questions.
Yeah.
So what do you think are some of the important factors that can lead to a successful startup?
Yeah. So I think, like I said in the beginning, the most important thing is to get the market right. Right? If the market is not right, no matter what you do, you're not going to succeed, right? And the other thing, once you get the market right, is to make sure that you're creating value in the system, right? So if you're trying to do the same thing that somebody else did and just grab a share of the market, that's not going to add value to the market. And as a result, the chances of success, sometimes people can succeed, but in most cases, that doesn't work out, right? So in general, in the world, you have to add value by bringing a new product, new service to the market. And that basically means innovation. That means solving a problem that was unsolved, possibly. And
so for many of our students who are excited about building their own startup and go for entrepreneurship, do you have any concrete suggestions for them, like how they can get started? And
So I think it's important to get a sense for what the pain points are in the neighborhood of something that you're trying to solve, right? And so, like I said, the first thing is to get the market right and understanding the market sizes and things like that, right? So most of us engineers like to go sort of solution first. And it's like, I have a cool idea around this algorithm or this system design or something like that, and let me go find a problem that can be solved using this. And that's a fine thing to do to get started, but once you're getting serious about sort of building a company, you have to completely reverse that thought process and say, okay, here's a problem that manifests itself in real world for these reasons. This is how valuable a solution to this problem is going to be somebody, and then work backwards from there, that what is needed. And in many cases, whatever brilliant idea you might have originally that should have caused you to go look in that direction may be completely useless. And if you found a valuable problem and you're going to engineer, you'll come up with some solution, but you don't have to be stuck to sort of your original brilliant idea for that. And like most successful things, it's kind of 10% inspiration and 90% perspiration. So being attached to kind of a brilliant idea is never a good thing. You have to kind of find the real problem and do everything in its service to come back to solving the problem. And Now, that's kind of a general advice. Now, coming back to starting a company, I think the most important thing after the market is to get the team right.
Yeah.
Right. Most big problems are never solved by one person, and I think the quality of solutions you build, the success of your company is a direct function of who you're working with, how well you work with them, how good is the chemistry, what kind of culture together you're going to create for the company. And so I think those things matter a lot more.
These are all great suggestions, and
Yeah.
I do agree. So what are some of the big challenges you think you and your team have met during the past few years?
Like what challenges we have kind of solved technically, or like as a company, what challenges we have gone through, and
as a company, what challenges have you gone through from the beginning to now?
Yeah, so it changes from different stages of the company, right? So in early days, I think our focus was to build the best possible team that we could build. And we were really, really successful in hiring some of the best engineers that you could find in the Valley. But it was not easy, and it took a lot of work and a lot of investment of time and energy to build that team. And that was probably the largest challenge. How do you grow this team fast enough, keeping the quality bar as high as we were trying to keep it? And that basically means meeting a lot of people, exploring their networks, and having a crisp and convincing story of what you're trying to build and why it should successfully add value to their careers and what they are trying to achieve. The next phase is usually about finding a sales motion. So actually, so you get a team, you have a product vision, you validate that product vision by sort of meeting a lot of potential customers and sort of making sure that you're still solving a very, very important problem in a way that people are accepting of. And then after that, you have some sort of alpha beta product. And then the question is, how do you find customers for it? How do you make sure that people who are trying your product early on represent your real customer? Because you can find a lot of false positives and false negatives in your early evaluation cycle. And so you have to find potential customers who are really going through the pain that you're solving for, and not someone who's just being nice and wants to give you feedback. And also someone who's a representative of a large group, so that if you solve the problem for them, you solve the problem for a lot of people, right? And then after that, again, it becomes a little bit about building a team, but now your sales and marketing teams, right? And sort of figuring out, how are you selling? Are you selling through channel? Are you selling through direct sales? Are you selling through free trials and online? What are your most effective marketing channels? What is the cost of acquiring a customer? How do you price your product? And a whole bunch of things around this go-to-market machinery that needs to get right for you to grow. And then once you have reasonable success in business, then usually the next phase comes which is kind of where we are at this point, maybe, although we've gone through a few cycles of it, right? So now you're at a stage where you have a reasonably successful product and a reasonably successful company. You need to grow it as fast as you can. And that means lots of different kinds of customers who are asking for lots of different kinds of things. And so you have to service to that. It means that now people are noticing your success and they want to do what you have done. So the only way to stay relevant is to do the next big thing. So while they catch up with you, you have a whole new sort of innovation that they didn't think about. So you have to innovate. And then once you deploy a product, invariably things go wrong, and you have to fix bugs, you have to support and have sort of DevOps kind of things. So, and at the same time, you have so much work to do now that prioritization is really, really important. And so how do you build good intuition around prioritization? Because in hindsight, it's obvious what worked, what didn't work, but you want to kind of, for each problem that you could potentially fix, you want to know what's the impact of that is going to be, how much effort it's going to take. And so where do you find the most leverage in the work that you do with the limited cycles that you have? And that tends to be kind of something that everyone struggles with and figures out their own way of doing things.
So do you actually analyze your own business using your own infrastructure to know like what's the next innovation? Do you get any insights using your own like business intelligence?
Yeah, we absolutely do. So we have our own instance that we like to call champagne. Earlier it was called dog food, which is kind of the industry terminology for using your own product, eat your own dog food. And we said, maybe dog food is not the right respectful name for it. We should be drinking our own champagne instead. And that means it has to adhere to a much higher quality as well. So yeah, we do drink our own champagne. In all of our Salesforce data, marketing data, product analytics data, all that flows into it. And we are constantly watching it for figuring out what particular sales segment is doing well, how did we perform in each of the marketing campaigns, which customers are adopting the product faster than the others, what's leading to that, what's causing people to drop out, and what can we do to fix it. So yeah, we use that a lot.
So how has the company changed over the past 7 years, and how do you think it will change in the next 7 years?
Yeah, so that's a great question, and I think what materially changes over the years. So few things change. Early on, it's all about building the product. Right? You have no sales, no customers, no marketing, and the entire company is focused on building the best possible product and innovating fast and coming to market. And then at some point you start introducing sales teams, customers, and partners as well. And then the focus of the company changes, and now you have kind of your own inward vision and about innovation, but then there are a lot of people telling you what you need to do. So that changes things a little bit. And then I think somebody told me in a way that made a lot of sense that there's this thing called Dunbar number. I think it's guessed that most people can actually know no more than 150 or so people. Keep them in there, keep their like sort of faces and names and what they do in their head. And so once the company kind of crosses that limit, then it's no longer possible to know everyone by name and face. And so that changes the feel of the company a little bit, because now you're interacting with people that you maybe never met or you don't really know. And then a little bit of the personal touch needs to be replaced with processes. And that changes the company a little bit. But I think what doesn't change is sort of the fundamental core values that you establish for the company. And it's not a given, but it's kind of, you have to consciously keep coming back to those core values. Like the core value that we have kind of defined is selfless excellence. And so excellence is about taking pride in your work and doing things in a way that you feel proud of it. And selfness is kind of everything is about the team and the company and not so much about the individual. So there are no rock stars in the team. There are no prima donnas. Everybody is willing to do whatever it takes to get the job done and sort of supporting each other and helping each other grow. And so that core value hasn't changed, and that's been a tremendous asset for the company.
Okay. So what about the next 7 years?
Next
few years.
Yeah, so we definitely want to build a company that sticks around for a generation. And, you know, as far as companies are concerned, there's never really a sustained flat line. Companies are either doing this or doing this.
Yeah.
So if we have to be around, we have to be growing.
Yeah.
So the hope would be that in the next 7 years, we grow a lot and the kind of problems we're solving and the magnitude of problems we're solving meaningfully grows substantially, and we touch a lot more people. I came from Google. A lot of early co-founders came from Google. And in my mind, Google is kind of one of the role models as a company to look up to. So I would love to kind of get to a place where ThoughtSpot is kind of kept sort of seen in the same layer as companies like Google.
So like, have you planned all this like sustainable growth in from all the way from the code infrastructure to how you build a team? And that's something I think makes Google quite successful.
Yeah. So I think the trick about growth is that like what got you here will not get you there. So at every stage you have to keep changing. We don't have sort of the financial resources and wherewithal to kind of build the same kind of infrastructure that Google has built for itself. But Google also didn't get there right away, right? So we always keep a certain fraction of our investments towards sort of productivity and building the right set of infrastructure and platform on which the next set of things will grow. And as the size of the team grows, that investment will keep growing. And then I think we will be able to hopefully do same kind of innovation that Google brought to the space.
Cool. So do you envision going to some different market or still stay in your current market?
I think data is like, we're all sort of very passionate about using data for creating value and good in the world. So far I'm not seeing us moving away from that, but how you use data and what do you do with data, I think will significantly evolve. So far we've been very focused on getting as much value as possible out of purely structured data, and that to the highest tier of data in terms of value, right? So for example, a lot of companies may have petabytes of data sitting in their logs, which is not as valuable as sort of terabytes of data that is about the transactions, the business transactions that the company goes through. And so we have focused mostly on the highest tier of data, which by definition is worthwhile keeping in memory, ready to be asked questions and kind of getting answered. So I see us expanding in terms of the type of data, so going from structured, relational to semi-structured and unstructured data. I see us growing in terms of scope to sort of more and more volumes of data, which may not on a per terabyte basis have as much value to the business. I see us also sort of changing the conversation around what you can do with data. So majority of the industry, if you look at the enterprise, is really looking at data more as a rear view mirror, right? And so sort of as more and more machine learning and AI is getting popular, people are started figuring out more interesting things to do with data. And not to say that they were not doing it, but the scope of that was, even today, in enterprise world, it's mostly about some sort of simple regression model or a decision tree kind of things, right? And that's what has made sense so far, but I see a lot more interesting things happening going forward.
Cool.
Yeah.
So let's maybe move on to more technical side.
Yeah.
And still relevant to the growth.
Yeah.
So what do you think are the top 3 technical problems you want to focus on in the near future?
Yeah. So on the machine learning front, the most important problem we are trying to solve is how do we surface the right insight from data to the right person at the right time that's relevant, right? So if you have a lot of compute power, you can compute a lot of different things, and not all of them may be relevant to the user, even though they may look statistically significant and anomalous, right? So an example of that would be that I could look at somebody's transaction history and say, you had an anomalous amount of sales on 4th of July. And they'll say, of course, I ran a promotion on 4th of July, right? So how do you figure out what's the right way to look at the data and find meaningful insights that are actionable that somebody will care about to deliver to them? And there's kind of a combinatorial explosion there in terms of what kinds of questions you can ask. And then how do you manage that explosion, both in terms of compute as well as in terms of relevance to surface the right insight to the right user. We have one of our customers, a bank down in Australia, where they basically put all their data in our machinery and ran Spot IQ, and it came up with a bunch of insights. And a lot of them were not relevant, but they found one that pointed to an anomaly where a lot of insurance claims were not adjusted. And from what I'm told, that was costing the company close to $30 million a year. And so this was putting the data into ThoughtSpot, pressing a button, and getting an insight that created that kind of business value. And this story is not unique. It has happened in every industry, in every vertical. In a lot of different cases, somebody found an anomaly in their travel expenditure data, where a lot of people were misusing a particular policy to buy first-class tickets, which the system was not designed for, and that was costing them several $1 million a year. Banking company found that when they borrow equity for their essentially options business, one particular bank was charging them an interest rate that was way higher than the market. That was costing them several $1 million. So there's usually a lot of interesting nuggets in the data that has very high business value, but getting to that is a very interesting problem. So that's one problem we are trying to solve. And in particular, one shape that it takes is that things are constantly changing, but not everything is changing. So people who look at dashboards every day come in and look at it, and most things don't change, right? So they almost get bored of looking at the same thing and stop paying attention. But every once in a while, something changes meaningfully. And how do you capture that one and surface that to the user? So that's kind of one problem that we are focused on. The other one is really about efficiency of compute, right? So we want to be able to get to answers as fast as possible, to as much volume of data as possible, with as little cost as possible, right? So there's always kind of, are there more efficient algorithms? Is there more efficient query planning? Is there a better tiering of where the data lives, whether it should be in that server's memory, it should be like you were proposing in sitting in the fabric somewhere on some other RAM, should it be like some sitting in some distributed file system that gets pulled in at the query time? And in particular, what has happened is that as most of the industry now is moving towards hosting things in cloud, which has great benefits in terms of like manageability, elasticity, availability, manageability, all those things. But it comes at a significant price as well.
Right.
So the same server that you can buy from Dell and keep in your data center, if you rent it from Amazon for 3 years, is going to cost you 10 times more. So that's just a fact of life. And so in that world, how do you bring the cost down of running a complex stack like ThoughtSpot is another big question. And we are constantly trying to speed up our queries as well so that we can sort of address more larger use cases with a better efficiency. So yeah. On the search side, I think it never gets done, right? So Google was probably the best search engine in the market in 2000 and continues to be, but there's no comparison between the Google of 2000 versus Google of 2020. So much innovation has gone into kind of understanding more and more of how users would express the question to how the system understands the question. We are in our own journey of sort of more and more semantic meaning and understanding of the real world and how people would like to ask the question and make it easier for them to express their questions.
Okay, so you mentioned cloud.
Yeah.
I found one thing interesting, especially for my own class, which is on cloud, is ThoughtSpot have 3 like business model. Like you do cloud, you have support for like running on VMware, and also support like running on bare metal hardware that I think ThoughtSpot sell. So how do these 3 buckets differ, and how do the technical side of ThoughtSpot change in these 3 markets?
Yeah. So initially, our hypothesis was that most companies were not ready to move their data in cloud, particularly the kind of data that we play with. So back in 2012, 2013, 70–80% of the companies will not talk to us if we said that it requires going to cloud.
Okay.
Today, the equation has completely changed. 70% of our new business is in cloud. Only 30% of the business is on-premise. And in fact, what I see is that 70% of our customers will not talk to us if we say that we don't have a cloud offering. Because most of them have kind of made a decision that no new infrastructure gets built on-premise and everything else is going to be in the cloud. On-prem, we could run, so we used to kind of take off-the-shelf hardware from Supermicro and put our software and sell that as an appliance. We don't do that anymore. So you can buy hardware from Dell or Avnet, and with a certain SKU, our software will run on bare metal because we made sure that everything kind of matches. Or if you don't want to get your server, those specific servers, then you can run it on any hardware as long as it has the required amount of CPU and RAM and networking, as long as you put VMware on it, and then we are VMware. And I think over there, what I'm seeing is that in our new business, a lot more is running on VMware than bare metal. The older business was primarily bare metal hardware, but the newer business is more and more of us just providing software that runs either on VMware or in the cloud VMs.
Okay. So for the cloud offering, so your software requires running on the VPC cloud service. So how, like, what type of customer feedbacks do you have for that perspective?
Yeah.
What do you think about running on like non-VPC, just
Yeah.
general purpose instances?
Yeah. So I think the industry is a little bit split. What we are finding is that this VPC model works really well for most of our customers who care a lot about data security, and their InfoSec teams really wants to own their own data security and the safeguards that they are putting up. So they want their own AMIs, they want their own configuration of the firewall around it. They want their own policies about when VMs get migrated from one hardware to the other and things like that. But at the same time, if you look at a company like Snowflake, they're fairly successful with saying that we'll primarily be doing SaaS. And I think the market is big enough that you can make that choice and walk away from a lot of customers who are not comfortable with it and still be fairly successful. And also, I think they have done a lot of work in terms of keeping the data encrypted as late as possible in the compute cycle, so that for the most part, data stays encrypted, and only when you're running queries at the late stage does the data get decrypted. So I think they've done a good job of just kind of educating the market around it, allowing for that. But we find it a lot easier to have the conversations with the IT and info security teams when we say, you just take our software, run it on your own infrastructure the way you like it.
Okay. Yeah. So I think that probably answers my other question about what do you think about running, like having customers running on their own account and then paying for both the cloud provider and paying for ThoughtSpot versus running everything in ThoughtSpot's account and paying only ThoughtSpot.
We haven't done that yet, but I've had a few customers who have asked for it, that I don't want to manage anything. All I want is a login and a password for my users, and they go in and they kind of interact with the system. I don't want to deal with AWS or Azure or whoever. You just give me a service. But that has been a small exception. And most of the large corporations that we're working with are actually very much concerned about where the data lives and who has control and who can get in when. And so they want to control it. It's also possibly because our market segmentation is somewhat unique. We tend to exclusively focus on businesses that have $1 billion or more in revenue. So we are very focused on global top 10,000, 20,000 companies. And we don't actively go after companies in the mid-market or small market, where there are fewer hands, and they would much rather have somebody else take care of everything and not have to worry about it.
That makes sense.
Yeah.
Okay, so what's your view towards some of the new technical trends in the cloud, like containers, serverless computing, and new types of hardware like non-volatile memory and hardware acceleration?
Yeah. So I think a lot of innovation happening, which is very good for industry. Each one has its own role. I think containers have kind of won already, and I think it's a settled debate. Even when we were starting in 2012, Kubernetes wasn't really there, and the container technology wasn't really there. So we had to build our own orchestration layer. We like to call it Orion, where it was very much modeled after how Google's Borg works. And what we are now doing is slowly phasing out parts of Orion and replacing it with Kubernetes. Because there's so much momentum behind it, and there's so many people who know how to operate these things, that it just makes sense. As far as hardware acceleration goes, I think it comes with a price. And so unless it becomes a standard, what you will see is specific niche markets where there's a lot of need for it, and it makes a huge difference, people going for it. So, for example, TPUs is a great example. There are a lot of machine learning workloads that just won't run anywhere else other than on TPUs efficiently. So that is kind of doing reasonably well. GPUs now have become mainstream and very general purpose. So I'm pretty sure that any technology built on top of GPU will do just fine. As NVMe again, I think kind of a lot of technology is evolving to kind of get near memory speed storage kind of thing. So Intel has been pretty bullish in pushing their Optane, and so you have like several choices as to sort of what speed, cost, and latent sort of density trade-off you want to do, and various people are settling on different places. But I think different applications will choose different one of these things, but I'm pretty sure that these technologies in themselves will be fairly successful.
Okay.
And I see a lot of excitement about serverless from some of the customers that I've talked about.
Yep.
I think what is happening is that the number of people who are building custom applications has grown significantly. And those applications may be dealing with large amounts of data, but the people with the skill set to build complex systems that can handle it has not grown.
Right.
So more of technologies that will allow kind of a developer with limited exposure to build complex machinery would succeed in markets. So in that sense, I think serverless should do really well.
Okay.
Yeah.
So the last part is actually related to academia and how academia and industry influence each other.
Yeah.
So has ThoughtSpots adopted some technologies that were originally invented in academia, or has any research results has influenced ThoughtSpots?
That's an interesting question. Obviously, there's so much that has come out of academia that has made its way into industry, and we are no exception. But if we talk about recent research, not so much. A few examples that I can talk about. I mean, like if you go down to like how Linux kernels were invented and how like original Volcano DB paper came out and changed the way databases were designed, and things like that. Obviously, we are using a lot of kind of what has become sort of standard techniques. We were developing our just-in-time compilation system for database around the same time that what's the name Hyper paper was published, and actually it so happened we were not aware of that paper when we built our first system, and it was several years later that we realized that this great paper was written, and we could have actually learned a few things from it. The search indexing system, we came up with our own sort of algorithm and data structure to do this very efficiently, which was inspired by data structure called Boolean decision diagrams that actually I had used quite a bit in my PhD research in the context of kind of hardware design and logic synthesis and stuff like that. I haven't seen any recent research paper that tackles that particular problem because that's so specific to the problem we are solving. On the machine learning side, we use things like SyntaxNet or BERT for language understanding. Yeah, I think that's the extent of.
So what do you think are some of the interesting problems
Yeah.
that may be valuable to your company, but
Yeah.
you don't have the immediate resource to work on, and therefore maybe it's a good target for academia research.
Yeah. So the problem I mentioned about finding relevant insights from data, I think that's kind of a very open-ended, Turing-complete kind of problem that we will take a very sort of industry-like approach to solving, which is take the tools that you have today and build whatever the best that you can. Whereas if you look at it from an academic research perspective, you can really think what's possible 5 years out from now, and how do you kind of put some theoretical underpinnings around it. So I feel that's very interesting. Same thing on the search side. Natural language understanding is far from solved, and particularly when you apply the lens of understanding natural language question as a SQL query. There's some interesting research happening in academia today, but I think for the most part, it's compared to the value it generates, it's kind of underrepresented. On the systems side, I can rattle off many things that are kind of very specific to what we do, but could make for an interesting research paper. So, for example, one of the things we were looking at was how should different partitions of data be placed on different servers so as to maximize our ability to parallelize a query, and as well as reduce the time for unavailability when a node goes down, so kind of moving things around quickly. And the assignments should have sort of almost an idempotent property that they don't keep bouncing around every time you try to compute them. That could be an interesting kind of a small sort of system design challenge. What I've found as a kernel of sort of when you're looking at speeding up database queries, a lot of things kind of come down to this kernel of how do you do a group by operation and how do you do sort operation as fast as possible, knowing all the things that you could have known ahead of the time. And that is a problem that I keep coming back to. Obviously, the obvious solutions are like you look at every record, you put that in a hash table, or maybe you sort of shuffle the data into different partitions and then do it on different nodes, and you have smaller hash tables. But essentially, at the end of it, either you're sorting the data, or you have a hash table in which you're kind of taking a new record and inserting and aggregating. And once that hash table grows beyond your L3 cache, every row becomes random access into memory. And I've been spending a lot of time just thinking about how do I speed that up. But there's a certain physics limitation to it. But I think if you can move the state of the art on that, that will dramatically improve so many things in databases.
It is more like a latency problem, a throughput problem?
Throughput.
Okay.
Yeah.
Interesting. Okay, so like maybe let's wrap up.
Yeah.
So some final questions.
Yeah.
Like, what do you think is the most attractive thing about ThoughtSpot? Especially for students?
Yeah. So I think when I was finishing up my PhD, I told one of my committee members that I wanted to find a problem that had really high impact in the world, as well as was very, very intellectually satisfying. That like I was thinking of new techniques and working on new things, and there was kind of a mathematical element to it, to solving it. And he basically said, "Good luck finding it." most people have to kind of choose one or the other. Either you kind of go into very theoretical stuff, which may not have a direct impact in the real world, or you get into systems where it's less about kind of sort of whiteboard mathematical thinking and more about kind of building systems, trying things out. And luckily, we have found kind of that place where we are working on very high impact problems that has a real meaning in the world, that kind of solves real business problems, that solves not just business, but like there's a cancer institute using our software to kind of help patients find other patients who have similar characteristics and kind of learn from their diagnosis. And there are a lot of other things where it's just kind of doing good in the world. But at the same time, we're working on really hard problems, whether it's a distributed systems problem, whether it's a machine learning problem, or a UX design problem. On all fronts, we are really moving the needle and trying to push the status quo. So that I definitely think a lot of people will find interesting. But the other thing, which is probably more important, is the culture and the feel of the place. So we realized that one of the biggest reasons why somebody would want to come and work at ThoughtSpot is because they want to start their company at some point.
Yeah.
And so they want to probably, while they're here, learn a lot of things about how to build a company, how to manage a company, learn about things that are not necessarily related to their function. And we openly embrace that. So we actively create that kind of culture and environment where you can learn and absorb as much as you want and you can. And there's a sort of strong support of mentorship and this kind of culture where this kind of thing is valued and cherished and not something that's kind of seen as a nuisance.
So have some of your former employees now become a competitor?
Not necessarily a competitor, but they have started their own company and they're on their journey to kind of build other successful companies.
That's very encouraging.
Yeah.
Do you have any final question for me? Or last message to students?
I think, yeah. So in terms of message, I think I can talk about technical things all day long. But what I've found is that the most important aspect of doing something substantial, doing something great, is A, having the courage to go where we don't feel comfortable, and B, just getting started and not wait for the perfect opportunity. So I think if you, and I see this across the board, it's not just about starting a company, it's also about being a great engineer. Some of the best engineers that I've worked with, I see them, if I ask them a question about how does a particular function in CLib works or how does Linux kernel works, they don't go read blogs, they go read source code, even though they have never read that source code before. And that attests to their courage of like, I can dive into a complex system and read the code and figure out in 10 minutes how that thing works. And so I think it applies across in different aspects of life, that just nothing important gets done without courage.